So now we're going to take a look at sort of increasing our sophistication as we write these little regular expression programs. So one of the things that we've been doing is we've been looking through files, looking for from lines, breaking them apart by spaces, and looking for email addresses, and even looking for domain names within them. And so let's sort of take a look at some of these things that we've done before in previous programs and how we can use regular expressions to make our lives a little bit easier. So here is playing with some non-blank stuff. So we're going to, if you recall, our goal is to sort of, we use split, we've used many different ways to extract this second chunk of stuff using spaces, and then we can pull the email address out. And we can write a regular expression, and to think to yourself, you think, oh, you know what I'm looking for is things that have @ signs in them, that's good. And I want to kind of go outward from the @ sign and stop at a blank. And so it's like find that thing and then go backwards, split until you find the blanks. Well, we can express that. We can express match an @ sign, and before the @ sign, I want a series of one or more non-blank characters. So \S is non-blank, plus is at least one. And then afterwards, I have some non-blank characters, at least one non-blank character. And then greedy, this is where greedy is your friend. Keep pushing, push, until you find something that fails, which is a blank character. So we have a blank here and a blank here. Or if you pushing all the way went to the end of the line, they would stop as well. But so it's like push outwards, find the @ sign, and then push outwards. And then we say, hey, find all the things that match this particular regular expression in this particular string. And lo and behold, we get a list. Remember that find all always gives us back a list that gives us exactly what we wanted. So we can, in a single line, use the regular expression library to find what we're looking for. We can fine-tune this a little more because maybe there's lines that have @ signs on them that we don't really want to even parse, don't even want to look at. So we can fine-tune this by saying, you know, I'm only interested in lines that start with from. And if we were writing Python, we could put a loop, or we could have if statement and do a continue. You know, we've done a lot of this, right? But here's a way with regular expressions to do it all in one little extending of the program. And I keep calling these little things here the program. That's the one we just built that says go through and find me lines that have @ sign with blanks before them. Okay. But we can use a new thing, and that is parentheses. So the parentheses here are, if you look at your quick guide, the parentheses indicate to the regular expression library the start and the end of what to extract. Okay? So this is a whole regular expression, and the parentheses aren't part of the line. So the parentheses aren't up in here. They're not in the line we're looking for, but they're part of the regular expression program to say, I'm going to give you a bigger match, but the only part that I want you to give me back in your return value is the stuff in between the parentheses. So it's like start here, start there, but match. So when we use the parentheses, and they're kind of implied here, we want the whatever matches. So the parentheses, unless you don't put them in, it gives you pretty much the entire thing that's matched. You know, greedy expansion and all that. But our whole regular expression now says, you know what, this is what I'm looking for. I want to find a line that has as its first 5 characters from, followed by a blank, this is a little blank here, followed by, and then parentheses says, start the match. Stop the match. Look for non-blank character, at least one, followed by an @ sign, followed by one or more non-blank characters, and then stop matching. And so here is what we pass in as the regular expression. And so that matches the beginning of the line from, and it matches the space, and then it finds non-blank characters, and it keeps on trucking along with non-blank characters, finds an @ sign, then it says I need some more non-blank characters, and then it stops here because it finds a blank here, and then it pulls the part, in a sense, the parenthesis wrap that bit. So even though this from and the space were part of the matching, which means lines that don't start with from will not give us anything, but we still pull out the thing that we want. So parenthesis is a way to make a longer regular expression and only extract a part of that, right? So parenthesis is a way to make a really long regular expression, but say, great, match all of it, but only return to me the part that goes in between the parentheses. And again, part of what you're doing is you're looking through data, you're throwing away data or lines that you don't want, and then parsing the lines that you do want. And this is a way of throwing away the lines that you don't want, and this is a way of parsing the lines that you do want. So if you recall, another thing that we did was we didn't just look for the email address, we looked for the domain name, which is the part after the @ sign. And so the hard way, the sort of low-level chopping way that we do it in Python is, if you recall, we said do a find. That means look from the beginning, find me the position, and that @ sign is at position 21. So find the @ sign. Look through here, find the @ sign. It's 21. Oh, okay. Then what we're going to do is we're going to look for the next space after the @ sign. So we do this, starting from the @ position, look where the space is at. Well, and that turns out to be 31. So now we have 31 and 21. And then what we do once we have 31 and 21, we basically say start at 22, which is 21 plus 1, up to but not including. That's what this slicing is, if you recall. Start at position plus 1 character beyond the @ sign, go up to but don't include the space. So that then carefully extracts the little piece. For some of you, you're like, that makes a lot more sense than regular expressions. And other of you like, whoa, I don't want to ever use this again. I want to use regular expressions for everything. It's okay, because different people sort of like different kinds of things in programming. They're doing the same thing, it's just harder. So this is sort of like the low-level, rugged way to do things. And we can do the same thing with regular expressions, sort of like we have to be a little more clever and we have to know our little programming language. But then once we do, we can do this a lot more succinctly. The other way we did this was with the double split pattern, if you recall. So if you recall, the first thing we did with a split was we split based on spaces. We split based on spaces, and that's what this line is, split based on spaces. And then what we did was we found the word sub 1, which is this guy right here. That's word sub 1, which is the email address, which is this. And then we did another split based on @ sign. So then that chopped it right here. And then pieces sub 1, because then that becomes 0 and that becomes 1. Pieces sub 1 was the thing after the @ sign, right? So here we have the pieces after this is the @ split, Stephen Marquardt and UCTAC.ZA, and then we grab the second one. So this is the double split pattern, where we split it on a blank, then grabbed a piece out, and then split that on @ sign, and then grab the second piece out. So that's another way to do it. So this is down to 4 lines to pull that information out. Now, if we're even more sophisticated, what we can do is we can say, let's look through the string until you find it. So do this with a regular expression. So our regular expression is look through the string until you find an @ sign. Boop, found the @ sign. And then the parenthesis says start extracting. And then what we have is one of these little bracket operators. So the bracket operator says a single character. And if the first character of the bracket operator is a caret, that means not. It doesn't mean the beginning of the line in this case. It's a programming language. Inside of the brackets, this means not. Anything but, and then this is a blank. That's a little blank character. So that says a single non-blank character. And then asterisk means that applies. This asterisk applies to this character because this is expressing one character from a set, the set of all characters that are not blank, as many times as you want, and then finish the extraction. And that's what it's doing. It's saying hunt for @, start extraction, keep going until you find a blank. Oop, we found a blank, so we've stopped it, and then we end the extraction. And so that's how that pulls out that @ sign. Okay, so now we've reduced this down to basically one statement. And we're just carefully expressing in our little programming language, using all of our cool special characters, how to do that. Now, just like before, we can say, you know what? We are going to look for the string from at the beginning of the line, followed by a space, followed by any number of characters, ***. So from at the beginning of the line, I insist on a space, then I'm any number of characters, *** is any number of characters until I find an @ sign. Okay, that's good. Then find an @ sign. Then we start extracting, and we keep going for extracting as long as they're non-blank. That's cool. And then we hit a blank, and then we stop extracting. So this is many non-blank characters is what that says. And then match many of them. And so that's a pretty sophisticated, like, hunt, find another thing, skip these other things, start extracting, extract this flunk, stop extracting, and then when we're all said and done, in a single line. And again, that sort of is the theme of these regular expressions, and they're like puzzles to figure out how you can express not only what you're interested in matching, but what you're interested in extracting, and the regular expression library does a lot of that for you. And like I said, you don't have to use this, right, if you don't want to. So here's a good example of a line of a bit of code that we did before, where we're extracting the spam confidence lines. And if you recall, we would open a file, right, and we're going to come up with a list of the numbers that we're going to read. We're going to loop through the whole file. We're going to strip the other stuff. Now, here's the interesting thing. Here, at this point in our previous implementations of this code, we would do, does it start with this thing, split it. Some of you did look for the colon and did whatever. There's some used find and then slicing, some use split. But what we can do is collapse all that into one simple regular expression that says, I am looking for lines that start with x-d spam-confidence colon space. So there's nothing programmy there. The caret is programmy, but the lines must start with this. This is really good at ignoring the data we want to ignore. It's like if it doesn't have that as the first, whatever, 16, 18, 20 characters, we're skipping the line. Okay? And then after that, you say start extracting. And then you look for a character that is a digit or a period. That's what this is saying. One character, 0 through in the range 0 through 9 or period. Inside of the brackets, this is not a wild card. It's not wild. Deuces are not wild inside of brackets. Dots are not wild inside of brackets. So this is because these numbers are going to be 0.9762 something. You want digits or dots, and that's what we're saying, digits or dots. And we're saying give me one or more, least greater than or equal to 1, and stop when you run out of digits. So it starts here, goes as many digits, and then stops there. Now remember that find all gives you back a list. And so the way I tell whether actually I found something on this line that did any matching, the way I do is I ask, is the list that I got back, is there one or more? Actually, in this case, I'm saying I only want ones where there's exactly one match. So it goes in and it pulls the thing out I want, and I get one match. And if the length of that returned set of matches is not 1, I continue, which means I'm skipping all the lines that don't start with it and have a number. And if not, I just pull the 0th one out, which actually pulls that number out, and then I append it, and then I do my max, and I do my other things. And so this here is a way of, well, when I combine these two lines together, these two lines are both selecting and extracting all in one statement. So like I said at the beginning, this is a little programming language, and it seems like it's, someone just typing on the keyboard and hitting random keys, and it certainly does look like that. But once you get good at it, it's very fun, nice puzzle. When you're writing programs for other people to read, don't get too excited about regular expressions. It's often fun to go to Stack Overflow and say, how can I do a regular expression to extract email, or something, an email address or something. You'll find people craft regular expressions and share regular expressions. Like I said, they're their own little kind of programming language. Sometimes you want one of these characters, like a $sign, to not be a code. And in that case, you simply you prepend it with a backslash. So $$ means real $sign as compared to the end of the line. And that way you can match things like $10 for cookies. So I hope you found this interesting. We're only going to use this in this chapter. I want to expose it to you because a lot of what we're trying to do in this class is read data. And once you get good at regular expressions, you can write more succinct and more reliable programs to scan and extract data using regular expressions. Don't feel like you have to use them, but some people love them. But they're a useful tool no matter what. And I just wanted to expose them to you and like give you an assignment so you could play with it. But we're not going to use it. We're not going to obsessively use it for the regular rest of the class, but you could if you liked. You know, some people will just use regular expressions from now on as they read data. And other people say, I never want to do this again. And both of you are right. So that's it. See ya in the next lecture.